Alrighty, this is our last FRQ in our FTC Part 2 set. We have a graph of g. We have f being g of x plus the integral of -4 to x of g of t dt. And for Part A, we want to find the value of f of 4. So you are just going to plug her in, see what you get. Oop, that's a t. G of t dt, well, that's going to be a 4. That's a 4. G of t dt. 4 is 2. Now, I am in a pickle because the integral from -4 to 4 is this mess right here. Now, I could do -4 to 0. That's fine because that's a triangle. But I can't really do 0 to 4 based off of triangles. Now, if we actually read the problem, it tells us that the square root of x is from 0 to 4 right here, which means I'm going to have to split up this integral from -4 to 0, aka my triangle, and then 0 to 4, aka the square root of x. Now, that triangle here, because it's below the x-axis, we know that she's going to be negative. So I'm going to do -1/2. Our base is 4, and then our height is 2. So far, so good in terms of these two parts right here. What's not going to be good is taking the integral of root x, because that one just gets a little bit messy. So we are going to up our power, and then we're going to divide. So that gives us 2/3 x to the 3/2. So we have 2/3 x to the 3/2 from 0 to 4. We actually have to evaluate this. We can't just say this and call it a day and stop here. So we'll take it one step further and evaluate this. And whenever I say evaluate, especially since this is an FRQ, just sub in. Now, do you have to plug in 0 here? Probably not, just because 0 is going to be 0, so we kind of don't really care about her. So in this case, our answer here would just be, ooh, I did not mean to use pink, but okay, that's my answer. Call it a day. Don't need to simplify here or anything. Just keep it like that. All right, part B says, show that f has a critical point at x is equal to -1, and then use the second derivative test to determine whether f has a local min or a local max at x is equal to -1. Show the work that leads to your answer. So it's telling you already that f has a critical point at -1, meaning that I'm going to verify that by taking the derivative of this, g prime of x plus g of x, f prime of -1 is equal to g prime of -1 plus g of -1. G prime of -1 is a slope, and that slope looks like 1/2. And then g of -1 also looks like a -1/2, which gives us 0. Now, because it literally told you to show that, you can't just say f prime of -1 is equal to 0 and call it a day. You actually got to verify and show it by showing the work here. All right, we wanted to use the second derivative test, so I'm going to go ahead and take the second derivative here. This is going to be g double prime of x plus g prime of x. All right, so f double prime of -1 is going to give us g double prime of -1 plus g prime of -1. G prime of -1 is going to be our slope here. Our slope we said earlier was 1/2. Now, that second derivative, though, because our original function g is a linear function at -1, that second derivative is going to be 0, which means that f double prime of -1 is 1/2, which is greater than 0. So then you have to give me my little statement here. Now, whenever you guys give me my little statements, please do not forget to include that f prime of -1 is 0. So f prime of -1 is 0, and f double prime of -1 is greater than 0. Therefore, f has a local minimum. You don't have to talk about concavity here. Just tell me that this is a local minimum and call it a day. Okay, this is something that we haven't seen in a while, where we want to find the value of the limit as x approaches 4 from the left of g of x minus g of 4 over x minus 4. Now, if you think about this logically, and I plug in 4 from the left, right? That's just going to give me 2. But g of 4 is also 2. And then 4 minus 4 is 0. So I have 0 on top, and then I have 0 at the bottom, so this is indeterminate form. But once again, you need to think about what you are given, okay? And what this might look like. In other words, this right here is the definition of the derivative given our limit right here. It's been a while since we saw her, but this is our limit definition here. That's 4. In this case, because it's g of x and g of x at 4 from the left is our square root function here, this is going to tell me that g of x is root x. And we want to find the derivative at 4 from the left. Well, to find the derivative from 4 from the left, I gotta take the derivative of this first. So g prime of x is equal to 1 over 2 root x. G prime of 4 from the left is equal to 1 over 2 root 4, which gives us 1 over 2 times 2, which is equal to 1/4. Honestly, you could have just stopped right here. But there's your answer. 1/4. All right, this is the end of FTC Part 2 in terms of FRQs. Unfortunately, we are still continuing our journey of FRQs. Like I said, we have 2 FRQs for this unit, and it is the most tested topic on the AP exam. So our next one is going to be rate in, rate out. Lots of fun.